Hello, everybody. In this recording, I'm going to try to keep things fast and streamlined because nobody wants to watch a 45-minute video of a simulated class period. So I'm going to try to move things along quickly. If something bothers you, if there's something you don't understand, please let me know. I'm happy to email back and forth with you. I'm happy to talk with you over spring break if you would like, etc. Okay, so I'm going to hop into the handout that's on Moodle. If you look at the Moodle page for today, section 4.3b handout, you should see that on there. And there it is. Okay, so what we're going to do today is develop a notion of power inside of a weighted voting system. The notion of power we will use is called Banzhaf power, named after John Banzhaf, who came up with the idea. And we start with this observation. A voter's weight in a weighted voting system might not actually tell you how much influence they have or how powerful they are. So today we're going to develop and use a measure of power in a weighted voting system that can sort of cut through the weights and tell you how much influence somebody has. In particular, we want to answer questions like this. If I have 8 votes and you have 4, then I have double the number of votes as you. Does that mean I have double the power? So if I have twice as much weight as you, am I twice as powerful? Is there a way that we can sort of measure power? And the answer is sure. You just have to be precise about what you mean by this word. What does that mean? If you can quantify that, then you can compare. And that's what we're going to do. So the learning goals are, please stop. So be able to calculate each voter's Banzhaf power index. That's a measure of power for each voter inside of the system. So I have to define this for you. This means nothing to you right now. Understand what a power index is trying to measure. So I don't want this just to be a black box. It's trying to measure power, but in a very particular way. And then given a weighted voting system, be able to use a calculator I'm going to show you to calculate the power of each voter. So most of our calculations, we're going to punt off to a calculator like we've done before, because the actual calculations aren't as important as the result and then being able to interpret it. Okay, so let's start with this example from last time. I'm not going to reread it to you because we've covered it, but you have a small company. You have 4 voters, A, B, C, and D, or 4 investors, each of whom becomes a voter with a different weight based on their investment amount. Things are passed by a simple majority, and there are 100 votes total. So here is the weighted voting system from last time. So now, voter A has 27 votes for their 27 shares. Presumably, they think they should have the most power because they invested the most money and therefore got the most votes. They should have the most power. Now, voter D, on the other hand, investor D, with these 22 votes, they shouldn't expect to have the most power, obviously. They should expect to have the least power. But if you ask them, they invested in this company, they paid money to get these 22 shares. If you ask them, should you have some power? They would say, yeah, I should have some power. That's why I invested, So let's see what the power dynamics actually are. So John Banzhaf had a really nice idea for measuring power. It's a really beautiful idea. It makes sense once you see it, I think, and once you get used to it, but it takes some real insight into power dynamics to come up with this idea. So what John Banzhaf thought was, well, first of all, let's just think about all the ways that a measure could pass. So what I've done for you here is I've listed out all possible winning coalitions in the system. So here are all possible ways that a measure could pass. A and B could team up together, A and C could team up together, and so on. All 4 voters could all agree that would pass something. Okay, so now once we have all possible ways of passing a measure listed out, let's plug into the vocabulary from last time and think about who's critical in each coalition. So we'll go coalition by coalition and see who's critical. Now, it should not surprise you that the idea of being critical is inherent to his notion of power. So being critical means that your vote means something, it means that you're necessary. So being critical somehow should translate into how powerful you are. And that was John Banzhaf's idea. So let me just show you how this plays out. So in this first coalition, we've done a lot of this last time, so I'm not going to belabor the point. A and B are both critical. If you remove A, B doesn't pass. If you remove B, A doesn't pass. So if you remove either voter, the resulting coalition is no longer winning. So A individually matters here. A is necessary individually, as is B. So if A and B team up, B cannot afford to make A angry, and vice versa. A and B are both individually necessary. In the coalition consisting of A and C, that's still true. If you take A out of there, the resulting coalition is losing. Same thing with B and C. So let's think about the coalition ABC. So in the coalition ABC, is A individually necessary? You know, is A critical? Could B and C afford to lose A if they wanted to? Could they afford to make A angry? And the answer is A is not critical here. B and C can pass a measure on their own. B is also not critical. C is also not critical. So in that coalition, nobody individually matters via the notion of criticality. Okay, so now in ABD, let's think about who matters there. If you take A out of there, let me write the weights, 27, 26, 22. If you take A out of there, the coalition loses. So B and D can't afford to make A angry. If you take B out of there, coalition loses. A and D don't have enough weight to pass something. Please stop. If you take D out of there, though, A and B can pass something. So D is not individually needed here. In the next coalition, ACD, so 27, 25, 22. So if you take A out of there, it's no longer winning. If you take C out of there, a combined weight of 49 is not winning. But again, if you take 27, 25, if you take D out of there, it doesn't matter. So D, again, is not individually necessary. Okay, so lastly, in this coalition here, B is necessary, C is critical, but D is not again. In the final coalition here, ABCD, nobody's critical there. So you can drop A out of there, still passes. You can drop B out of there individually, still passes. Okay, so John Bonsoff said, let's think about all the ways that a measure could pass, think about who's critical in each coalition, and then for each voter, let's just count how often their opinion matters. So how often is A critical? How often is A actually needed in a coalition? So if I just count, there's an underline, there's an underline, underline, underline. A is critical in 4 different coalitions. So what does that mean? There are 4 different ways to pass a motion where A is really needed. A's opinion really matters there. And for B, we could do the same counting, B, 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 still 4 ways. C, if you count up the underlines 4 ways, D, 0. So what John Bonsoff thought was, well, A is critical 4 times, B is critical 4 times, C is critical 4 times, D is critical 0 times. There are 12 possible times in the system that somebody's opinion matters, right? 4 times for A, 4 for B, 4 for C. So there are 12 times where somebody's opinion matters. And how many of those times belong to A? 4 of them do. So he created what's called a Bonsoff Power Index. That's the BPI there. So the Bonsoff Power Index of the given voter is the number of times their opinion mattered divided by the total number of times that anybody's opinion mattered. So of the 12 times that somebody's opinion mattered, 4 of those belong to A. So that's about 0.33. And same thing for B. And same thing for C. Now, by contrast, D, when does D's opinion matter? The answer is never. D's opinion actually never mattered on an individual level. So 0 out of 12 belong to D. So what Bonsoff's idea was to do this and basically frame each person's power as a percentage. So he's saying like A has 33% of the power in the system, as does B, 33.333, as does C. But poor D has 0% of the power in the system. So what does this mean? This means that D should be very angry. D invested money to get 22 shares that translated into no power, literally zero power, right? Zero. There was no time when his opinion mattered, individually mattered. Now, voter A, I think, should also be kind of angry because voter A paid the most money, but they have the same amount of influence as C does. So who's happiest in this situation? I think it's voter C. They have the same amount of power as A, and they paid less money to do that. Okay, so anyway, this is John Bonsoff's idea, is to create what's called a power index for each voter that shows you what percentage of the power they have. So A has 33% of the influence in the system, so does B, so does C, whereas D has no influence, right? Again, there's not even a possible situation in which D's opinion mattered. We did not underline D anytime. So since there's no time when D's opinion mattered, they have no power, despite their 22 shares. So again, this number might be misleading. This number right here, like 22 shares, seems like it should give you some influence, but it doesn't. There's no time when that 22 mattered, individually mattered. So that's Bonsoff's idea. Okay, so the Bonsoff power index of a voter X, denoted with this BPI notation that I used above, is the number of times this voter is critical divided by the total number of times that anybody is critical. So this number gives you a percentage of the time that the given voter matters. They were necessary when compared to all times that somebody's opinion mattered. And notice it says here, these indices add up to 100%. So you're thinking of like, basically Bonsoff's idea was take the amount of power in the system and divvy it up like a pie, say, well, you got 20%, you got 60%, whatever. So it's telling you like what percent of the power you have in the system. Okay, so here's an exercise. Now, if I were you, I would just pause the video and see if you can do this, but I will quickly go through this for you. Here's just the next example. So suppose a city council has 4 members, A, B, C, D, plus a mayor, M, and they all have an equal vote. The mayor, however, only votes when there's a tie among the members of the council. So if there's a split, a 2-2 split, the mayor votes. No matter what, majority vote is required to pass something. So I've listed here all winning coalitions. Let's see who's individually necessary. Okay, so in this coalition ABC, who's critical there? Well, if I drop C out of there, for example, AB on its own doesn't pass because AB is a 2-2 split without the mayor. So C is necessary. And by the same token, so is A and B. So that same logic means everybody's critical and all those 3-person coalitions without the mayor. Now, in this ABCD coalition, this coalition here, nobody's individually critical. You could drop D out of there and it still passes. Okay, so now let's go over to the coalitions with the mayor. So if I drop A out of there, the coalition BM doesn't even exist because the mayor only votes with 2 people. So that's a losing coalition. It's not going to win. So if you drop A out of there, the mayor drops out too, and it loses. And same thing for B. And again, if you drop the mayor out of there, there's a 2-2 split without the mayor's support. So the mayor is critical. And the same logic applies to all of these. So this is such a small system with such a small margin of error, if you like, that a lot of criticality here, right? People's opinions matter a lot. So A, B, C, D, M. Let's get the counts. Okay, so A, 1, 2, 3, 4, 5, 6. So 6 times for A. And I think the same thing is true of B. Let's see. So B, 1, 2, 3, 4, 5, 6. Same thing for C, I think. 1, 2, 3, 4, 5, 6. So you see where this is going. Same thing for D. 1, 2, 3, 4, 5, 6. almost missed one. And the mayor, there's just 6 down the line. So there are 30 total critical hits inside the system. So the BPI of, for example, A is 6 out of 30, which is 20%. And that'll be true of all of them. So it'll be 20% all the way down. So in the system, even though the mayor doesn't vote a lot of the times, every time he does vote, he's critical. So the mayor has the same amount of power as any other council member. So again, one of the nice things about this power measure is it can cut through sort of like, well, questions of, I mean, again, because the mayor doesn't vote that often, you can ask, like, aren't they less powerful than everybody else? And the answer is no. So this notion of power cuts through like maybe your bad intuition about how a system like this behaves. So here's an example where there's an equal power split. Everybody has 20% of the power here. Okay, now I just did 2 examples by hand. We listed out all possible ways that a measure could pass, did the underline thing, did the counting, and we got the Bonsoff power index for every voter. You don't want to do that often, especially for larger voting systems. So this example had 4 voters. This example had 5 voters. The European Union, I should have looked this up ahead of time, but has like 28 members or something, 28 voters. You obviously don't want to deal with 28 voters like this. It would take forever. Same thing for like, this tiny company only had 4 shareholders. Imagine having 2,000 shareholders or something who have like voting rights. You don't want to list everything out like this. So what we're going to do instead is let a calculator do it for us. And here's the link. And what you do is you just enter the weighted voting system and then it tells you. So I want to show you how that works for this one that we just did. ABCD with those shares, and the quota was 51. So I'm going to stop sharing on here. I'm going to hop over to my laptop. If you click on that link for the Bonsoff power calculator, it takes you here. It should look something like this. Now you ignore basically everything on this page. You scroll down. I mean, it gives you some references to where you might look. So Bonsoff invented this in 1965. But you scroll all the way down here and you have to fill in 3 boxes. So first it says number of members or players. So players in the weighted voting literature just means voter. So in our system, we have 4 voters. The quota is 51. And then it says here, enter the weights with no punctuation. So there's no commas here. So I'm going to type 27 space 26 space 25 space 22. And then I click calculate indices. Now, when I do that, it's going to show me a bunch of stuff. Penrose index. What's that? Who cares? All we care about is this column. And this is in the handout. It tells you just look at this column. That's all you care about. So there's my third value, my 33% for A, 33% for B, 33% for C, and then poor D gets nothing, 0%. So this column here gives us what we want to know. You're going to ignore everything else. This swings column, by the way, tells you these critical numbers, if you care about that. So A was critical 4 times, as was B, as was C. So this column is also maybe relevant because it tells you the critical hits, but this is the column we really care about, this middle one here. Okay, so that's what we're going to use. So I'm going to quit hopping back and forth between my iPad and laptop because it's kind of obnoxious to watch. But I'm going to do it one more time. Here is an example from last time. So let's see how powerful each voter is. Now, in particular, when we ended class last time, I zeroed in on these 2 voters, 8 and 2. Does that voter B have 4 times the power as the last voter? They should, maybe, if they're investing or something. And we also focused on A and B. 13 is bigger than 8, quite a bit bigger than 8. So shouldn't that top voter have more power than the second voter? I mean, probably, but let's go see. So again, this is the last time I'm going to hop over like this, but I do want to show you the calculator again. Okay, so I'm going to go back. So in this case, there are 5 voters. and the quota was 25. Again, you just clear this out. So delete and then type 13, no comma, 8, 6, 3, 2. And by the way, this is what you do in your homework. So if it asks for the Bonsall power index, you do this. Okay, so here we go. I'm going to write this down back on my iPad so we can reference it. BPI of the first voter is 33%. BPI of the second voter is also 33%. BPI of the third voter is 20%. And then the last two voters each have like 7% of the power. Okay, so I'm going to hop back over to my iPad and then quit doing this hopping thing. Okay. So I just copied that down. So now let's go back to our questions. A and B. A probably expects to have more power than B, but they do not. Those two numbers are the same. So if you're A, you're thinking, well, why did I invest so much more, maybe, right? Or if you're thinking about countries, you're thinking my extra population got me nothing extra, you know, I'm so much bigger than state B, but I get no extra power. So that's the first thing to notice. Even though A looks like they might be more powerful, they're not. Now let's think about comparing 8 and 2. So 8 is 4 times 2. Does that mean that B has 4 times the power? And the answer is, well, let's take 33 and divide by 7 and see what that is. I'll just ask my calculator for that. So B is 4.7 times more powerful when you compare 33 to 7, more powerful than E. So we expected maybe that B was 4 times more powerful. They're actually roughly 5 times as powerful. So if you're E here, you're thinking, what? How do they pick up that extra like 1 percentage point of power, right? Or whatever the measure is, right? I thought they might be 4 times more powerful, but they're actually like 5 times more powerful, you know? So again, one of the uses of this measure is you can cut through the weights to see relatively how powerful are people. So even though A has a lot more weight than B, it turns out their opinion matters just as often as B does. So they don't have any more power than B. You know, you can make observations like this. It's really nice. Let's just do one last one, just real quick. So look at C and D. C has twice the weight as D, but they have more than twice the power. When you compare 20 to 7, that's almost 3 times more power. So if you're D and you're looking up at C, you're like, what? What happened there? They have double my weight, so I know they have more power, but how does double weight translate to 3 times the amount of power? But again, that's the usefulness of this measure. It can tell you things like that. You don't have to worry about the weights so much. The weights can throw you off when it comes to power dynamics. Okay, just a couple last examples. These are all the examples we did last time. Oh, and it has the same typo. Okay, well, I really should have fixed that. But anyway, too late now. I've been recording this for a while, so we're in too deep. All right, so this one here, you have a senior partner that gets distinguished. There was the weighted voting system. Now, I kept saying last time over and over again, being able to write things in that notation is useful. And now we can see why, because once you write in that notation and you want to know about the power dynamics, you can scurry right over to the calculator and see. So we're going to think about what the Bonsall power index is of the 4 voters. Now, the Bonsall power of B is the same as C, same as D. So A is the only special voter here, right? B, C, and D are all the same because they do have the same weight. If you have the same weight, you have the same power. Okay, so I'm going to come back to my calculator and type that in. Again, I'm not going to keep hopping back and forth because it's obnoxious to watch, but there are 4 voters. the quota is 3, and I type 2, 1, 1, 1 with no commas. And what it tells me is the power of A is 50%. So A's opinion matters half the time when somebody's opinion matters. And then the other 3 voters have like 17% of the power. So even though A has double the weight of the other partners, he does not have double the power. He has roughly triple the power. So that's a nice observation to make. Okay, now example 5. It was the same law firm, but now ties are broken by the junior partner losing. Now in class, nobody asked this, but when you just read these casually, you might think, what's the difference? You know, so in one case, we got a senior partner, and in another case, we got a junior partner. Does that really matter? And the answer is, well, let's see. So here was the weighted voting system that multiple people gave us last time. So again, since you can write that down, you can go to the calculator and ask, how powerful are people? So again, in this case, A, B, and C all have the same amount of power because they have the same weight. And then D will have a separate amount of power. So again, I'm not going to hop over to my laptop in the Zoom meeting, but I'm just going to type now a quota of 4 and now 2, 2, 2, 1, calculate indices. And it turns out that the top 3 partners just share a third of the power each, 33% of the power, and poor D gets no power now. So at least up here, the junior partner's opinion matters sometimes, and he had some power. But down here, the junior partner's opinion matters not at all. So these are definitely not the same weighted voting systems. If D has a say in things, he should really root for this. Right? That's good for D. This is bad for D. Okay, last one. Last example. So the UN Security Council, we set up a weighted voting system like this: 39 quota, 7, 7, 7, 7, 7, and then a bunch of 1s. That's what we set up last time. So each permanent member has like 7 votes, and each non-permanent member has 1 vote with a quota of 39. That's what we did last time. Now let's see how powerful the countries are. Does the US have 7 times the amount of power? So I'm going to come over here, and there are now 15 voters, and the quota is 39, and I'm going to type with no commas, 7, 7, 7, 7, 7, spaces in between them, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 10 ones. I click calculate indices, and for these, the power is 16.69%, whereas for these, the power is 1.65%. So the US has like 17% of the power in the system, as does China, as does Russia, whereas a country like Egypt or the Netherlands or whatever has only 1.65%. So if we compare those, so compare 16.69 to 1.65, you're going to get about 10. So 16.69 is about 10 times larger. Let me just do that. So it equals 10.12 or so. Okay, so what does that mean? That means the US is more than 10 times, is 10 times more powerful than, again, Brazil or a country like that. So even though it looks like the US is 7 times more powerful, it's not. It's actually quite a bit more powerful, 10 times more powerful, slightly more than 10 times more powerful. Okay, so what's the punchline of today? The amount of votes that a voter controls might not accurately reflect how much power that voter has, especially in relative terms. When you're like, oh, I should have maybe, I have 3 times the weight. Does that mean 3 times the amount of power? That's what I mean by relative terms here. Okay, so there are 2 voting systems down below, and you should practice these in the calculator. This one here, even though 9 is really close to 10, those 10s all split the power equally. and the 9 loses out. So you can ask the calculator for the Bonsall power index for each voter, and that's what shakes out. So again, if you just sort of like casually looked at that system, and you might think, well, 10 is really close to 9. So that 4th voter should have about as much power as any other voter, but that's not true. That 4th voter has literally no power. Their opinion never matters individually. Now, by contrast, again, you should practice this on the calculator. In this system, every voter has 25% of the power, even though 3 is much smaller than 8. Okay, so again, that's why this notion is useful. Now, the very last thing I'll say is, next time I want to give you some historical context. So I want to practice with this concept more and give you some historical context. Now, John Bonsoff is not the only person who came up with a notion of power. We're going to cover his only because otherwise it's kind of overkill. And his is like the most common in the literature, but it's worth pointing out there are other ways to think about power than this. But this, again, if you've processed the definition here, this is a pretty natural notion of power. Thinking about how often does your opinion matter relative to how often do other people's opinions matter. So if your opinion matters 4 times, and there are 12 total times where people's opinions matter, I mean, you have 1/3 of the power. It's a very natural idea once you've processed it. Okay, so now on Monday, again, we're going to practice with this concept more, and I'll give you some interesting historical context for it, and then we're done with this unit. So again, if something confused you or bothered you, make sure you let me know, and I'll see you on Monday after spring break.